Hopefully, as you progress through this chapter, you've noticed that there are all types of compound statements that seem to have identical truth value outcomes. If two compound statements have identical truth value outcomes, then they're known as being logically equivalent. And logically equivalent is identified or is labeled as this equal sign here, except it's an equal sign with three lines. So what we need to do for this problem, this first problem here, example one, it says determine if the compound statement if P then Q and not P or Q are logically equivalent. So we do that by comparing their truth values once we make their truth tables. So we're going to go ahead and make a truth table for each one of these. So the first thing I'm going to do is I'm going to make the standard outcomes here, the standard truth values for P and Q. And of course, for the first simple statement here, the first half of the values are true and the second half are false. And then we just alternate it for the second one here. And then notice that we do have a negated P here, not P. So I'm just going to go ahead and I'm just going to put that in because we're certainly going to need it. So I like to list it right away since I spot it. And of course that negates P over here, so this is going to be false, false, and then true and true. Now I'll go ahead and build this if P then Q. If P then Q. And we know that for a conditional statement such as this, if P then Q, when the antecedent is true and the consequent Q is false, then the whole statement is false. So when the antecedent is true and the consequent is false, then the entire thing is false. Other than that, it's going to be true. Now we'll go ahead and we'll make the truth table for not P or Q. This is a disjunction, and of course for a disjunction, this statement has to be false, and this statement has to be false for the entire compound statement to be false. Or you could also think of it as at least one of them has to be true. So I have a false and a false right here. So this is where it's false. Other than that, it's going to be true. So now as we compare the truth values for each table, when P is true and Q is true, I've got true and true. P is true and Q is false, I've got false and false. When P is false and Q is true, I've got true and true. And when P is false and Q is false, I have true and true. So these are identical. So since they're identical, then we can say that if P then Q is logically equivalent to not P or Q. We're going to do the same for example 2, the same approach for example 2 here. It says determine if it is not true that P and not Q is logically equivalent to not P or Q. So we'll do the same thing. We'll go ahead and we'll put in our standard values here, P and Q. And then I could see that I have a not Q right here, and I have a not P, so I'm just going to go ahead and list them. That's just a personal preference that I have. False, false, true and true, false, true, and then false, true. Now I can go ahead and do inside the parentheses here, P and not Q. Again, this is a conjunction and statement. This has to be true, and this has to be true for the whole thing to be true. So it's true right here, and it's true right here. That's where it's true. Other than that, it's going to be false. Now, of course, we negate this clause, so we'll do that. It is not true that P and not Q. And we negate these statements. True, false, true, and true. Now I'm going to build this compound statement here. Not P or Q. This is a conjunction. That's where both the simple statements have to be false for the whole thing to be false. So it's false right here, not P. And it's false right here for Q. So this is where it's false. Other than that, it's true. So as we compare the truth tables, they're identical. So since they're identical, the statement, it is not true, P and not Q, is logically equivalent to not P or Q. So it works.